In this video, we are going to talk about the multiplicative transformations of the graphs of the sine and cosine function. And let's get started with this particular example here. Here, we want to graph 1/2 sine of x and compare it to y equals 1 sine of x. Okay, so let's go ahead and look at this table here. So when x is equal to 0, sine of x is 0. Divide that by 2, and we have that 1/2 sine of x is equal to 0. When x is pi over 2, sine of pi over 2 is 1. 1/2 of that, 1/2. 0 divided by 2, 0. At 3 pi over 2, or 270 degrees, the sine is negative 1, and then 1/2 of that is negative 1/2. And of course, we're back to the zeros at 2 pi. And what do the graphs look like? Well, here you go. This right here is sine of x. It varies between 1 and 1, has the period of 2 pi that we expect, and this is the graph of 1/2 times the sine of x. And as you might have guessed, it is basically this graph shrunken by a factor of 2. And notice that whenever this value is between 0 and 1, we are going to have a vertical shrinking. And that is just an indication of the main thing that I want to mention for this particular part is that whenever you multiply sine or cosine by a particular number, you either are going to get a vertical stretch, like what you have here, if that value is greater than 1, and you're going to have a vertical shrink, which is what you have here when that value is between 0 and 1. And then value a also gives rise to the amplitude. Now keep in mind, a can be a positive number or a negative number, just can't be 0, because if it is 0, then we have that y is equal to 0. Okay, well, if that's the case, then the range of the function is, instead of being from negative 1 to 1, is going to be from the negative of the absolute value of a to a. And then the amplitude, or what we're going to define as the amplitude for both of those functions, will be the absolute value of a. So keep in mind that a is always, or the amplitude is always going to be a positive number. In fact, it's going to be that value right there. Now, what about the case where instead of multiplying the entire function by a particular value, we multiply the argument of that function by a particular value? How is that going to behave things? Or how's that going to make things change? Well, kind of remember when we multiply the entire function by a certain number, we had stuff happen vertically. Here, we're going to have stuff happening horizontally. And let's take a look at what happens when we actually try to graph sine of 1/2 x and compare it to y equals sine of x. Okay, well, for the case when x is equal to 0, sine of 0 is 0, and sine of 0 divided by 2 is 0. However, when x is equal to pi over 2, then 1/2 of that is going to be pi divided by 4, which is also 45 degrees, and the sine of 45 degrees is the square root of 2 over 2. When x is equal to pi, x over 2 is pi over 2, which is also 90 degrees, and the sine of that's going to be equal to 1. When x is equal to 3 pi over 2, half of that is going to be 3 pi over 4. Which, by the way, is 135 degrees. But that puts us in quadrant 2, so we still have root 2 over 2. Now, half of 2 pi is pi, sine of pi is 0. Half of 5 pi over 2 is going to be 5 pi over 4. And that is the same as 225 degrees. Essentially, that is a reference angle of 45 degrees in quadrant 3, which means it's going to be negative, and we have negative root 2 over 2. Half of 3 pi is 3/2 pi, okay, which is 270 degrees, and the sine of 270 is negative 1. And then 7 pi over 4, half of that is going to be 7 pi over 2. I'm sorry, 7 pi over 2, half of that is going to be 7 pi over 4. That actually is 315 degrees. Reference angle of 45 in quadrant 4, so it's going to be negative. And then half of 4 pi is 2 pi, and we have 0 there. So when you compare the graphs, here is y equals sine theta, the one in the dotted red. And if you'll notice, it actually has a period of 2 pi, which is what we expected it to have. However, sine of 1/2 x, it takes 4 pi to do a revolution. So what you've noticed is that when we multiply the argument by 1/2, we get a horizontal stretching. And if we multiply the argument by something greater than 1, we actually have a horizontal compression or horizontal shrinking. And that's basically what we want to point out here is that if you actually take sine of x, multiply the argument by b, and if b is greater than 1, you are going to get a horizontal shrinking, or probably in a more appropriate term would be a horizontal suppression. Okay? If that value happens to be between 0 and 1, then we have a horizontal stretching. Okay, that applies also for both sines and cosines. And this gives us some insight into how to compute the period for a transform function. And this is what you want to do. If you have the equation y equals cosine bx or sine bx, then your period is going to be 2 pi divided by b. Clearly, when b is equal to 1, you have, as you might expect, 2 pi. So with this information about period and about amplitude, let's go and take a look at example 3. There it is. Okay, so here we want to look at the equation y equals cosine 1/2 x. And the first question is, what is the period? Okay, from our previous slide, we know that the period is going to be equal to 2 pi over b, which in this case is 1/2. Okay, this is the same thing as 2 pi times 2, which is 4 pi. Okay, what about the amplitude? Well, since there's no value here, we can just assume that's going to be a 1, and that means that our amplitude, usually given away by capital A, is going to be equal to 1. And now we can move on and and do the next part, which is this. Here we want to choose the correct graph. Now keep in mind, period is equal to 4 pi. It's going to take 4 pi for it to do one complete revolution. The amplitude is equal to 1, which basically means the graph should range, in terms of y values, the graph should range from -1 to 1. Okay? And that basically, so with that in mind, since the period is 4 pi, and this basically has one complete revolution in pi radians, this can't be it. Nor can this be it. So it must be this graph or this graph right here. Now, the amplitude is 1, right? So here, the full scale is 2. So this varies between -1 and 1, and so does this. So the fact that the amplitude is 1 does not exactly help us. However, if we look at one basic point, when x is equal to 0, that is going to give us that y is equal to cosine 1/2 times 0, which by the way is just cosine of 0, which will be equal to 1. Okay? Now, when x is equal to 0 here, that's -1. That can't be the graph. This must be the graph. And that is all that I have for this particular video. In our next video, we will look at a few more functions which may or may not serve you well in your homework. And if you have any questions, please feel free to contact me. This is Bob Boyle, signing off.